Hello students, how are you all? Hope you are fine and doing well. I am your chemistry teacher Md Eusuf Ali and today we are going to learn about nucleophilic substitution reaction. It is a very important reaction of organic chemistry. So before going to the topic nucleophilic substitution reaction, we have to know what is nucleophile. Nucleophile are those substances which donates electron pair in the reaction mechanism or electrophile. So it is a electron rich species such like OH minus, NH2 minus, Cl minus, etc. So here nucleophile donates electron pair to make a covalent bond to the electrophile. So now we are going to learn about nucleophilic substitution reaction. So at first we have a haloalkane Rx, that is a haloalkane. X means halogen group and R means alkyl group. So if that reactant reacts with a nucleophile OH minus, then we get a product ROH. So here we can say OH minus, that is hydroxyl ion replaces X or this halogen atom. So here X minus will be left. So here OH minus replaces X. So that is a substitution reaction. Here OH minus is a strong nucleophile and X is a weak nucleophile. How can we tell a strong nucleophile and weak nucleophile? The donating atom, smaller the donating atom, nucleophile will be stronger. So OH minus is a strong nucleophile and X minus is a weak nucleophile. So what is nucleophilic substitution reaction? The substitution reaction in which the strong nucleophile replaces weak nucleophile is called nucleophilic substitution reaction. Clear? Now remember that nucleophilic substitution reaction, in short we can write SN. So SN means nucleophilic substitution reaction are two types, SN1 and SN2. SN1 means one for unimolecular nucleophilic substitution reaction, and here 2 stands for bimolecular nucleophilic, N for nucleophilic substitution reaction. So nucleophilic substitution reaction are mainly two types, SN1 or SN2. Now pause the video and you can write down in your notebook or can take a screenshot of that. Now we are going to discuss about SN1 reaction mechanism. SN1 reaction mechanism takes place by two steps. In step 1, that is carbocation generation or generation of carbocation. So if we take a haloalkane, that is BrCH3, this is a tertiary butyl bromide. And if we add a polar solvent, then here Br is a bromine is a electronegative atom than carbon. So here partially negative charge and in carbon partially positive charge. In polar solvent, bromine atom leaves away from the alkyl halide and form carbocation. So here Br minus is generated and here a carbocation is formed, CH3 and CH3, that is a tertiary butyl carbocation. Here it is a 3-degree carbocation. So how we call that 3-degree carbocation? Here on that carbon atom which is positively charged attached with another 3 carbon. Here this carbon has positive charge and it is attached with another 3 carbon atom. So here it is a tertiary carbocation or 3-degree carbocation. In hyperconjugation, we know that 3-degree carbocation is a more stable carbocation than 2-degree or 1-degree carbocation. And step 2, that is attack of nucleophile. So here that carbocation, tertiary butyl carbocation, attacks by nucleophile. It can happen by two sides. Here OH minus attacks from the right side, so we get a product CH3, OH, CH3, and OH minus can attack from the left side, OH minus. So we get a product CH3 and CH3. So it is a mechanism of SN1 reaction or unimolecular nucleophilic substitution reaction. Here it happens by 2 steps. At first step, generation of carbocation. Here carbocation, more stable carbocation is formed. And in step 2, nucleophile, attack of nucleophile. Now we are going to discuss about SN2 reaction, that is bimolecular nucleophilic substitution reaction. So here we have a reagent, that is hydrogen, that is methyl bromide বা bromomethane or bromomethane, that is bromomethane. When a nucleophile attacks on bromomethane, that is backside attack is occurs. OH minus attack from the back side of leaving group Br. Why backside attack? Here carbon is a partially positively charged and bromine is a partially negatively charged. So OH minus is a nucleophile, so attacks on positive center, that is carbon. Here OH minus attacks on carbon and bromine leaves away. Here a transition state is formed. What is transition state? Transition state is a very unstable state. So here we can write a transition state, that is C. Here 3 hydrogen, I write 3 hydrogen, and C carbon, the bond between carbon and bromine are breaking. So we can show the breaking of bond by the dotted line and formation of a bond between carbon and oxygen or OH. So here carbon and bromine bond is breaking, so we can show by a dotted line, and a bond formation between oxygen and carbon we can show by a dotted line. So this is a transition state, it is a very unstable state between reaction mechanism. It is called transition state, and we get a final product, that is hydrogen C, hydrogen and OH. So we can say, you can see the difference between these two molecules. Here bromine is replaced by OH group, so we can say it is a nucleophilic substitution reaction, and it happen on a single step. So write down here backside attack is possible, and this reaction is a very fast reaction. So write down, or you can take a screenshot of that. Now we differentiate between SN1 and SN2 reaction. SN1 means unimolecular nucleophilic substitution reaction, SN2 means bimolecular nucleophilic substitution reaction. So at first SN1 reaction is a slow reaction. Slow reaction. Why slow reaction? Here you already know that SN1 reaction happens by two steps, occurs in two steps. First step is a carbocation generation or generation of carbocation, that is a very slow step, and SN2 reaction is very fast, is a fast reaction. Here SN1 reaction, there is carbocation is formed. Carbocation is formed. Here transition state is formed. In SN1 reaction, backside attack is not possible, or we can write it is a two-step reaction. SN2 is one-step reaction or single-step reaction. Here in SN1 reaction, that is backside attack is not possible. Backside attack of nucleophile is not possible, and here backside attack occurs. Backside attack of nucleophile. So why in SN2 reaction backside attack occurs and in SN1 reaction backside attack does not happen? Here we already know that in SN1 reaction here 3-degree carbocation is favorable. So in 3-degree carbocation, in 3-degree alkyl halide, here the carbon attached with 3 larger group. Here 3 larger group. So here steric hindrance is occur. What is steric hindrance? Steric hindrance is the repulsion between larger group. In SN2 reaction there is no steric hindrance or steric effect. So here backside attack is possible and here backside attack is not possible. And number 5, reaction rate of, it is a very important point, rate of reaction does not depends on concentration of nucleophile, and here rate of reaction depends on concentration of nucleophile. So we can write the rate of reaction proportional to the concentration of substrate, that is tertiary butyl bromide and nucleophile. Rate of reaction depends only on the concentration of substrate. So here we can write 1, and nucleophile does not depends on nucleophile concentration. So in the power of nucleophile we can write 0. So the molecularity of reaction, what is molecularity? The number of molecules in which the rate of reaction is depends. So here we can see the rate of reaction depends only on the substrate. So molecularity of the reaction is 1. That's why we can call it a unimolecular nucleophilic substitution reaction. In SN2 reaction, rate of reaction depends on methyl bromide as well as nucleophile. So here molecularity, we can see the molecularity is 2. The rate of reaction depends on 2 molecules. molecularity of reaction is 2. So that's why we call it a bimolecular nucleophilic substitution. Another important point difference is here 50% inversion and 50% retention of configuration occurs. Here 100% inversion occurs. 100% inversion. That point we will discuss later in another video. So it is some difference between SN1 and SN2 reaction. SN1 reaction is very slow reaction, SN2 is fast reaction. Number 2, carbocation SN1 reaction, carbocation is formed, here transition state is formed, 2-step reaction, here SN2 is 1-step reaction or single step reaction. In SN1 reaction backside attack is not possible, in SN2 reaction backside attack of nucleophile is possible. The rate of reaction does not depend on concentration of nucleophile, so molecularity is 1, and here rate of reaction depends on concentration of nucleophile, that is molecularity is 2. And another most important point is in SN1 reaction is favorable for 3 degree alkyl halide, then 2 degree, then 1 degree alkyl halide and alkyl halide by haloalkane or haloalkane. And here rate of reaction is more for 1 degree haloalkane, then 2 degree, then 3 degree. So now write down or take a screenshot of that. Now write a question, arrange them according to the rate of SN2 reaction. One is CBr CH3 tertiary butyl bromide, that is number 1. CH3Br methyl bromide or bromomethane, that is number 2. Ethyl bromoethane CH3CH2Br, that is bromoethane, that is number 3. And number 4, isopropyl bromide CH3CH3Br, that is isopropyl bromide. Or now how we can answer the question. Here you can see the bromine attached with that carbon, so here no another carbon is present. Here the carbon, that is bromine, the carbon with brom. How we can write the answer of this question? So here you can see that is a 3 degree haloalkane, 3 degree. How you can tell that is a 3 degree haloalkane? So here bromine attached with that carbon is also attached with 3 carbon, another carbon, so it is a 3 degree, and this is a 1 degree haloalkane and this is a 2 degree. How? The carbon which is attached with bromine is also attached with 2 another carbon atom, so here it is a 2 degree, or it is a methyl bromide or bromomethane. So we already know that the rate of SN2 reaction is 3 degree is 3 degree, less than 2 degree, less than 1 degree, less than methyl halide. So we can write the answer is rate which is more for SN2 reaction, that is number 2, 2 greater than 3 greater than 4 greater than 1. And number 1 reaction, it is favorable for SN1 reaction but not for SN2 reaction.